This has a light on it. So. I'm gonna lock this door. Locks with this.
Whatever. Oh, you're kidding me.
Oh,
Hello, sir. How are you doing?
Pretty good. How are you?
I'm all right, sir. How's your health?
All right. Think I'll be all right.
Yeah. Yeah.
Recording.
Good afternoon, everyone.
Hey, good afternoon.
How you feeling this week? You all right?
Yeah, I think I'll be all right.
Yeah, no, I hit my hammer on my toe too. It really hurts. So I wasn't able to print out my homework because I forgot it.
What do you mean you forgot it?
I've got it on my Microsoft Word,
Yeah,
but I didn't print it out.
all right.
Can you
don't
see?
you don't have your Microsoft Word on your computer?
No, I do. I do. I've got it here. I can't show it. I can't, hi, there's my homework,
Oh, okay, yeah. Yeah, you don't have to show it to me. I believe you.
I was just thinking, oh shit, I forgot to print the thing out and I don't have a printer out here.
Well, in the future, you can remember to take care of that.
That's the ticket. And I forgot a highlighter too. That would be a good thing.
Yeah, that's a good idea. We usually give you one of those if we meet in class.
Oh, actually, I'm glad you said that because now these little pens they gave us have a highlighter on the top. That's
Yeah,
right.
that's right. That's right. The Peterson's pen. Yeah.
Yeah.
No extra charge either.
Yeah, that's what I'm saying.
All right.
And you know what's really nice about it is that child-proof cap.
Yeah, there you go. All right, we might as well get started here. Earlier today, I sent everybody the class schedule. Did everybody get that?
Yeah.
All right. Any problems with that? Basically, the outline showing you what we're going to do class by class for the rest of the term. The only thing of real importance on there is on the back, there's a couple of email addresses you can get get in touch with me if you need to, but by now you probably know my email since all you have to do is respond to the one I sent you, and that'll be that. All right. Last time I saw you was 2 weeks ago on Monday, on Wednesday, and I assigned homework number 1. So hopefully you're in a position that we could take a look at that and review that now. That sound fair?
Yep.
All right, homework number 1 should be on the screen in front of you. All right, why don't we start with Stephen and Migby?
Yes, sir.
How you doing?
I'm good, sir.
All right, how about one of you take question number 1?
Okay. A boiler is a closed pressure vessel in which water under pressure is transformed into heat by the direct application, is direct into steam by the direct application of heat.
That's exactly right. That's all you need to remember. All right.
Yep.
The key word there, they're going to ask you on the test, is it an open or a closed vessel? And of course, it's a closed vessel. All right.
Yeah.
Very good. All right. How about Dominic for question number 2?
A pressure vessel is a vessel in which pressure is obtained by an external source or applying heat from an indirect or direct source.
Okay, I'll buy that. Can you give me an example of a pressure vessel?
An air compressor.
There you go. A compressed air tank, a deaerator. All are very good examples of compressed air tanks. What the hell is that background noise? Let's see here. All right, we'll figure that out eventually. All right. All right. Question number 3, Jeff Lopez. Jeff Lopez, are you out there? How about Nicholas McDonald?
Yeah, I'm ready.
All right, question number 3.
So it says, how often are high pressure boilers inspected? I missed last week. I'm just seeing this for the first time. I was stuck in an airport last week.
All right. All right, fair enough. All right. You want to take a stab at it?
I'd just be guessing.
All right.
I'm not really sure.
All right. Anybody else want to take a stab at number 3?
I will.
All right, go ahead.
Yearly.
Okay. All right. What they're actually looking for is all boilers operating over 15 PSI shall be inspected internally and externally every year. What's the difference between the 2 inspections?
Inside inspection and outside inspection.
Very good. And can the boiler be running during the internal inspection?
Not a chance.
Not a chance. Very good. So it's actually 2 different inspections. All right. An internal and an external.
Right.
And that's what they're looking for. So good. All right. How about Tommy Medeiros for number 4?
Yeah, I got name of owner, user, location, size and number of boiler, date of inspection, signature of inspector, maximum allowable working pressure, location in the boiler room, engine room, where it can easily read.
Excellent. That covers everything. Nice job. That's everything. Beautiful. Question number 5, David Boyd.
Which air tanks require inspections? Any air tanks 50 pounds or greater, and the inspection is every 2 years.
Excellent. Compressed air tanks, unless otherwise exempt, over 50 PSI have to be inspected every 2 years. Excellent. All right. Number 6, Joshua Estrada. How about,
I see him, I just can't hear him.
yep, I can see him too, but,
Can you use sign language? There we go.
I had it on mute. Refrigeration equipment, unless otherwise accepted, over 20 tons shall be inspected every year.
excellent. Exactly right. Beautiful. All right. All right. How about number 7? Jim Gibbons.
Require periodic attendance, boiler horsepower 9 to 250.
Okay, require periodic attendance. Beautiful. All right. Why don't we stay with you, Mr. Gibbons, and why don't you take number 8?
Boiler horsepower is 251 to 500.
For non-continuous attendance? Excellent. And how about number 9?
501 or greater.
Okay, great. Over 501 boiler horsepower for continuous attendance. Nice job. All right. All right, Joe Lane, how about number 10?
What can you do with a second fireman's license? You can operate any boiler or boilers under the engineer or fireman in direct charge thereof.
Excellent, excellent. All right, they're gonna ask everybody that, everybody that's going for second fireman. All right. Greg Lovett, number 11.
Who can appeal the results of a license exam? I had anybody that's disgruntled or didn't think that the professor was, or they didn't think they were treated fairly.
Okay, that's pretty close. What the law actually says is anybody aggrieved by the decision of a single examiner has the right to appeal. All right, so you're gonna be pissed off at one inspector. All right.
So don't go out and piss the rest off.
There you go. Is it a good idea to appeal?
No.
Bad idea. Bad idea. Take your beating, resubmit your application, take the test again. All right. All right, how about number 12? Who didn't I call on?
I'll take it. I got for incompetence or untrustworthiness.
Okay, all right. That's exactly right. Why would your license be suspended or revoked? Remember, the day you take the test. Joshua, I don't know what that background noise is. Somebody's running the tub. I got to put you on mute there. All right.
Yep.
All right. Yeah. But remember, the day they hand you the license, it says you have been duly examined and you have been found competent and trustworthy. So the state law says the only way they can take it away from you is if they find you incompetent or untrustworthy. All right. So that's that. All right. How about number 13? Back to Stephen Amigby.
Number 13, we have dual low water cutout.
Say it again.
We have dual low water cutout.
Okay. Okay. All right. Fair enough. All high pressure boilers require 2 low water cutouts. All right. What's the difference between the 2 low water cutouts? Anybody?
One has to be manually operated.
Excellent. The second one has a manual reset. Someone has to physically be in the boiler room to reset it. Okay. Very good. All right. Number 14, Dominic.
Dual pressure controls are not permitted.
Excellent. That's all you got to say. Dual pressure controls, which allow the boiler to operate as a high pressure boiler some of the time and as a low pressure boiler the remainder of the time. That is not legal. It's not permitted. Everybody kind of gets that, right? It's either or. All right. And then finally, number 15. All right. Nicholas McDonald.
Yeah, I'm sorry. I'm struggling over here. I'm trying to open these up.
Okay. No problem. No problem. How about Tommy Maderas?
How you doing? Yeah, this one's kind of long, so I'm just gonna read it off the book.
All right.
I need a date and time, continuous blow down, surface blow down, valves open, gauge glass blow down, blow water cutoff tested. Auxiliary equipment checked, boiler ignition verified, boiler room clean. What was the internal conditions observed when the boiler was open? Any operator notes, signatures of license and number of operators.
Excellent, excellent. All right. Again, the purpose of that question is that you've seen the logbook, you know what information is on it. And the only question they ask you is what information is not on that logbook. All right. So in that logbook, are you going to put there's contractors on the premises? No,
Yeah.
no. So you get the idea. All right. So that's a good thing to memorize and remember. So what's going to happen tonight? I will send you the answers. Jesus. I will send you the answers to these homeworks and on email, and you can keep them with your answers to make sure that we're on the same page as we move forward. Any questions about homework number one? All right. Homework number one is extremely representative of the questions they'll ask about chapter 146 on the state exam. So I'm not saying that's all you need to know, but it's a big chunk of it. All right, very good. Let's move on. All right. Tonight's topic, boilers. Should be the next section in your binder. All right. Now, I know many of you have probably seen boilers, all right? But the bottom line is this: boilers are classified basically as fire tube or water tube boilers. Has anybody heard that expression before?
Yep.
All right. A fire tube boiler pictured here, all right? And I think a lot of you have seen these, all right? Cleaver Brooks, it's got the market kind of cornered on these things. These things are the most common boiler in Massachusetts, all right? This is a fire tube boiler, which means the products of combustion travel inside the tubes, which are surrounded by water. That is the definition of a fire tube boiler. All right. If anybody's seen one of these, you'll know that as you approach this boiler from the front, it has a hinged door that opens up and it exposes the tube sheet and the furnace. All right. As you move towards the back of the boiler, it also has a rear door that can be opened up. All right. The fire is initially inside this furnace tube, this big opening. The products of combustion come to the back of the boiler. There's a baffle across that tube sheet right here that forces the gases through these lower tubes back to the front of the boiler. All right. Where they then hit another baffle, travel through the lower half of the upper tubes to the rear of the boiler, and then finally make the last pass out of the boiler. All right. How many people have seen these before? All right, Tommy, where did you see this?
I actually started off punching tubes when I got into facilities. So yeah, I've seen plenty of those, or especially in the Cambridge area for Biomed Realty and all those other companies out there.
Okay, all right. So you actually took a brush, a wire brush, and punched and pushed it down each tube to clean any
Yeah.
ash out of the tubes?
Yeah, yeah. And then I did that, for my first year, and then I got to train newcomers or interns how to do it. And then if the combustion wasn't right, they'd come back to me just covered in soot. So it was actually kind of comical to see it. But
All right, pretty good. All right. That's pretty good. We'll talk more about these type of boilers, but the other type of boiler that you're likely to hear about in this business is a water tube boiler. All right. In a water tube boiler, it's now the water that's inside the tubes surrounded by the products of combustion. All right. You might want to write this down. Water tube boilers generally operate at higher pressures and have more capacity than a fire tube boiler. They're bigger and they can deliver more steam at higher pressures. All right. This shows you a water tube boiler being retubed. They're putting new tubes in it. All right. Today, most water tube boilers have an upper steam and water drum connected by tubes to a lower mud drum. All right. And that's basically the design of the boiler. Does everybody kind of get this? All right. So the fundamental difference, fire tube, the products of combustion is inside the tubes, which is surrounded by water. And in a water tube boiler, the water is inside the tubes, surrounded by the products of combustion. And we'll talk about the various types of boilers as we move on. All right. Today, boilers are also classified by their relative position to the floor, meaning they can either be horizontal or vertical. Most fire tube boilers today are what they call horizontal tube boilers. Excuse me. Most water tube boilers today are vertical boilers. And everybody kind of gets that. It's a subtle difference, but important. All right. What you and I are interested in are how we use boilers. You and I are most interested in what we call stationary boilers. They are permanently mounted in a facility and they're not going to move. Everybody gets that, right? The boilers are generally located in the boiler room. All right. And that's where we go to operate them. All right. Some plants have portable boilers. If your boiler breaks down, they can bring in a temporary boiler on the back of a flatbed trailer. All right. Hook it all up and run that boiler right out in the parking lot, providing steam to the facility. All right. Guess where you might find a marine boiler?
On a boat.
Yeah, on the boat. All right. You and I can never run the boilers on a boat, but the guys who run boilers on a boat can't run stationary boilers. All right. Two different worlds. All right. All right. Boilers can also be classified by the location of the furnace. They can either be internally fired or externally fired. Make yourself a little note here. All boilers today are internally fired. We'll talk about an externally fired boiler tonight. All right. And then finally, the boilers are classified by the pressure they operate at. Remember, does anybody remember what's a high pressure boiler?
Yep. Anything over 501.
Anything over 15 PSI?
Anything over 15 PSI is considered a high pressure boiler. Anything 15 PSI or less is considered a low pressure boiler. You don't need a license to operate those boilers. All right. There's a whole group of boilers out there today, what they call special purpose boilers. And we'll talk about those momentarily. Now, as far as you're all concerned, all right, most boilers today, I'm talking 95% of all boilers, operate on the principle of natural circulation. All right. So 95% of all boilers work with natural circulation. All right. And just so you get that, all right, that means there's a difference in temperature between the heated water in the boiler, which rises, and the entering feed water, which is cooler. The difference in density causes that cooler feed water to sink or travel downward. The heated water rises, and that creates natural circulation in the boiler. You've probably observed this if you've ever boiled water at home. All right. You notice that the water closest to the flame heats up first, and the steam bubbles travel to the surface. And the water that's furthest from the flame, all right, travels downward. And that creates the natural circulation. All right. Boilers that operate above 2000 PSI require circulating water pumps that actually circulate the water inside the boiler. Those boilers are known as controlled circulation boilers. Not many of those out there, but they exist. And then finally, there are what they call forced flow boilers, often referred to as once through supercritical boilers. All right. These boilers operate at extremely high pressures and produce tons of steam. All right. The only one you're going to get asked about as second fireman are natural circulation boilers. So that's really all you have to worry about. All right. Boilers are also classified by draft. I'm pretty sure everybody's heard of this. All right. But remember, the original boilers were connected to a chimney. And this worked on a very simple principle that air pressure here was higher than air pressure here, which means air mixed with the fuel tended to rise and travel out the stack. Natural draft. All right. Today, all boilers use fans to push the air into the boiler, all right, to create the draft. All right. If the fan is located at the front of the boiler, it's known as a forced draft fan or an FD fan. If the fan is located after the boiler, it's known as an induced draft fan or an ID fan. Some boilers use both forced draft and induced draft fans, and they call those boilers balanced draft. All right. We'll talk more about this when we talk about combustion. All right. Any questions so far? All right. Good. Now, this picture right here in your book shows a controlled circulation boiler, which means that there are boiler circulating water pumps that take water from the steam and water drum and pump it into the bottom of the boiler. This forces the water to circulate upwards through the boiler. You can see this boiler operates at around 3,250 pounds per square inch. All right, pretty high. All right. This picture shows a picture of a forced flow steam generator. All right. This boiler operates above the critical pressure of steam. You can see the boiler pressure in this boiler is 3,675 PSI. All right. This boiler makes 4 million pounds of steam an hour. All right. This particular boiler ran a generator to produce electricity about 650 megawatts. So this is a big boiler. All right. All right. They're not going to beat you up on this stuff. All right. I just want to show you the different types, different styles of boiler. All right. Probably the most significant specialty boiler today are what we call heat recovery steam generators. Has anybody heard that term? All right. These boilers often don't have burners in them to burn fuel, but rather they take the exhaust off some type of engine and use that waste heat to generate steam. The most common configuration today is they use a gas turbine, basically the jet engine off an airplane, that's hooked up to a generator. The hot exhaust gases go into the heat recovery boiler, generate steam, and that steam is piped to a steam turbine, which drives the second generator, cogeneration. All right. This is the most common type of plant they're building today. This is the only thing that's been permitted in Massachusetts for the last 25 years. All right. There's one of these plants, and let's see, Dayton, all right, Charlton, Everett, Bellingham. All right. So no matter where you live, you'll probably hear about one of these types of plants. All right. Nobody's heard of this before? All right. All right. Now, just before we get too far into this, I want to make sure everybody understands what you're getting into. All right. Boiler operations, pretty boring business. In fact, the way it was described to me, 99% boredom, 1% terror. All right. All right. The truth is, you may never see any terror at all. This is an extremely boring business. All right. Is anybody actually doing the job as a boiler operator right now?
Yeah,
All right, Joshua, tell us about it.
yeah, just like you said. I mean, mostly boredom, but you do your rounds. You have a couple of things to do: backwash polishers, check on things, make adjustments, water chemistry. So not a bad gig.
How much work do you actually do over the course of a shift?
Over 12 hours, maybe 2 hours.
Okay, that's pretty good. That's pretty fair. All right. All right. Now, do you work alone, Joshua?
It's just me and the control guy.
All right. So 2 guys on a shift, huh? Right.
Yeah.
All right. So the only time you see anybody else is when you change shifts.
Pretty much.
All right. All right. And like Joshua said, it's mostly routine, taking readings. All right. Occasionally, you might have to start up or shut down a boiler. That might break up the day. But the bottom line is this: you are there for emergencies. All right. Emergencies may never happen. And I want to emphasize that. All right. A lot of people get nervous when they hear this. They say, oh, I don't know. I like that. All right. You might go 45 years and never see an emergency. Does everybody kind of get this? Is anybody still interested in this? Now, because there's so little to do, most companies today ask that you do a little bit of maintenance. All right. Routine stuff, check on things. All right. Check on the auxiliary equipment, the pumps, all the equipment that makes the boiler room run. All right. Necessary. All right. You might get involved in a boiler inspection. You might get involved in a hydrostatic test, a visit by a state inspector. All right. You might lay up the boilers. All right. This is extremely boring business. Now, you've got to have the right personality for this. All right. Joshua, tell them what happens if your relief doesn't show up for work.
Yeah, you suck it.
You stay there. All right.
Yeah.
All right.
Especially if they don't call or don't show up. You got no indication.
Everybody gets that, right? So after working 12 hours, you're counting on the guy, your relief, to come in. All right. Sometimes they get waylaid, they can't make it, they're sick, something happens, you get stuck. Right. All right. What I want to do here is show you the different types of boilers. All right. So you can identify them just by looking at a picture of them. All right. That'll be part of the state exam. All right. They'll ask you about, how they operate. All right. In addition to what they look like. All right. Does everybody kind of get this? All right. Nothing's top secret here. There's nothing that's rocket science. It's all basic stuff. All right. Now, the earliest boilers, all right, and I'm talking 1800, the end of the 17th century, were what we called vertical fire tube boilers. It was a vertical shell filled with water that had tubes extending from the furnace right out the top of the boiler to the stack. All right. You built a fire, usually coal, by opening the door and throwing in a shovel full of coal. All right. These boilers were dogs with fleas. They were not very efficient, but they boiled water and made steam. All right. They no longer make these, but there's one question that they still ask about them. There were 2 types. The dry top, known as the exposed tube type, and the wet top, known as the submerged tube type. And the difference was this. In the dry top, the normal water level was about here. And these upper portion of these tubes were not surrounded by water. They were in the steam space. The advantage to this dry top boiler is it could make a little bit of superheat. The wet top, on the other hand, the water was above the upper tube sheet, so the tubes were always submerged in water. All right. This boiler could only make saturated steam. That is steam at a temperature corresponding to its pressure. All right. Which of these was better? The wet top was considered the superior boiler. When you first started these boilers, you didn't have any steam. So the tubes in the dry top would expand and contract at a different rate. All right, leading to leakage. They were prone to leak. Whereas the wet top never leaked. Right? The tubes always grew and contracted at a uniform rate. All right. That's the only thing they're going to ask you about vertical fire tube boilers. The next boiler is probably the most famous boiler. All right. This guy was called the HRT boiler. And often that's all they ask you about this boiler. What does HRT stand for? And it stands for horizontal return tubular. And what happened in this boiler? You built a fire underneath the shell. The products of combustion traveled to the rear of the boiler and traveled inside the tubes and out the stack. All right. So the hot gases of combustion made two passes through the boiler. All right. Made it twice as efficient as a vertical fire tube boiler. All right. What they look like was a big shell supported by a brick setting. Everybody kind of get the idea? You'd open these upper doors right here, throw in a shovel full of coal. When the time came, you'd open the lower doors and remove the ash from the ash pit. All right. Being a fireman back then wasn't much fun. All right. Work. Eventually, they got smart and they said, all that water in the shell resting on the brick setting was causing the boiler to settle. So what they did, they supported the shell of the boiler by overhead suspension. All right. Just an improvement in the design of the boiler. All right. The other thing that was kind of troublesome was this. Up until World War II, how we constructed pressure vessels and boilers was by riveted construction. All right. I shouldn't have to tell you this, but in 1971, the United States prohibited pressure vessels from being built using riveted construction. All right. Today, all boilers are welded construction. All right. And I think everybody understands that. All right. On the state exam, they're going to ask you two questions. What are the most two important welded joints on a boiler? All right. The first one is what they call the longitudinal joint, and it runs the length of the shell of the drum. I think everybody kind of understands this. All right. How they make a boiler is they take a flat piece of metal plate, they roll it to form a cylinder. And then they weld it to form that longitudinal joint. Everybody kind of get that? The benefit of welding is this. If you use the proper welding rod, the welded joint is 100% efficient. It's as strong as the material. All right. In fact, there's only two efficiencies for welded joints, 100% and 90%. The efficiency of riveted joints was all over the place. All right. The other important welded joint is what they call the circumferential joint. That's the welded joint that attaches the tube sheets to each end of the cylinder to form a closed pressure vessel.
Repeat that, please.
Yep. The other important welded joint is the circumferential joint. That's the welded joint that attaches the tube sheets to the cylinder to form a closed vessel.
So the two most important joints was the horizontal longitude and the circumferential joint.
Circumferential joint, also known as a girth seam. All boilers today have those two welded joints. Now, you guys should be able to figure this out. What's missing in this picture right here are the tubes. What's going to happen? They're going to put a tube through every tube hole. Some boilers might have as many as 300, 400, 500 tubes in them, depending on its size. All right. Here's the cool thing. When they put the tubes in the boiler, they're not welded. All right. There's no welding. The first thing they do is they place the tube in the tube hole. They stick a tool in it that expands the tube so it fits tightly in the tube hole so it doesn't leak. All right. And the second thing is they beat over, usually with a hammer, the end of the tube. All right. That keeps the tube in tension and the two tube sheets from bulging out. All right. One of the major problems with all fire tube boilers today is that they have flat surfaces. All right. Does everybody kind of get that? All right. In a perfect world, what shape do you want a pressure vessel to be in?
Slightly bowed.
Yeah. How about just round? All right. Have anybody seen a compressed air tank? Anybody ever see a square one? All right. Trust me on this. All our pressure vessels are round. That's because anything with pressure in it, the pressure, the internal pressure, wants to cause that flat surface to bulge out. If we already make it round, a hemispherical head, for instance, it sets up less stress on the material. All right. So the main problem with package fire tube boilers is they have a flat surface. Everybody kind of gets that, right? All right. Everybody get what I'm talking about? All right. Flat surfaces are bad. All right. In all fire tube boilers today, the tubes themselves support the flat tube sheets. The area above the tubes, they utilize diagonal stays, and the area below the tubes, they use through stays. All right. Does anybody know why? At the top of these boilers is a manhole. Anybody know what the manhole is for?
Internal inspections.
Internal inspections. All right. So if there were stays running through this boiler, would you be able to get in there?
No.
So these diagonal stays allow access for inspection and cleaning. The area below the tubes, there's not enough room for a person to get in there. So they're supported with through stays. All right. Now, this page basically shows you everything they can ask you on the state exam about HRT boilers. All right. Probably the most common question is that this boiler was externally fired. Does everybody get what that means? All right. They literally built the fire underneath the shell. The products of combustion travel to the back of the boiler and then pass inside the tubes and out the front. All right. Externally fired. All right. Most of these boilers, when they were first built, were pitched towards the rear. If this was the front, this was the rear. All right. The reason they did that, as you boil water, the impurities stay behind in the water as dissolved solids, sludge, sediment. The blow-off pipe on the HRT boiler was located at the back of the boiler. What they wanted was all this crud to kind of settle near this pipe. So when I opened these valves and I removed water from the boiler, I'd get rid of the sludge and sediment. Everybody kind of get that? All right, pretty straightforward. All right. What happened? All right. And the reason they thought of this was this. Remember, this boiler was hand fired by coal. So you'd open up a little door here, throw in a shovel of coal, and this made this area right here the high temperature area of the shell. If all the sludge and sediment were to settle evenly across the bottom of the shell, you'd build up a layer of crud here that would affect the heat transfer of the boiler, and the high internal pressure in the boiler would cause a bulge in the shell. All right, does that make sense? All right, so they were pitched or sloped towards the rear head. After World War II, something very funny happened in this country. All of a sudden, we had a lot of oil. So what they did, they converted a lot of these boilers to burn oil. They had knocked down that bridge wall. They'd install an oil burner, which would put the high temperature area of the shell back where the blowdown was. All right. So what they'd do then is change the pitch of the boiler and install the blow-off pipe in the front of the boiler. So one of the questions they used to ask second firemen, what's happened to the boiler if they moved the blowdown pipe from the rear to the front? All right. And all they did was convert it to burned oil. All right. Any questions? All right. Now, has anybody ever heard the term a reinforcing pad or plate? All right. Picture this. The shell of an HRT boiler on average was about 3/4 of an inch thick. To install the blowdown pipe, they would drill a hole and thread the hole for the blow-off pipe. All right. That didn't give that blow-off pipe a lot of support. So what was a typical fix was they would install a reinforcing pad or plate, another thickness of metal that they'd attach by welding or riveting. They'd drill a hole through it, and that would give them better thread penetration for the blow-off pipe. All right. So the question on the state exam is, where on an HRT boiler would you find this reinforcing pad or plate? And it would be on the bottom of the shell at the blow-off pipe. All right. Any questions? And if you remember from that picture I first showed you, the blow-off pipe had to extend out through the rear wall of the setting so you could operate the valves out here. All right. That pipe had a lot of stress on it, so they typically used a reinforcing pad or plate. All right. You know, they're not going to ask you the typical diameter, but one of the things they like to ask is this: what are the proportions of fire tube boilers? And what they're asking you is this: the length of the boiler was usually 3 times the diameter. All right. So when you look at a fire tube boiler, that's the ratio. All right. How the thing is constructed. All right. Tubes were 2 inches to 4 inches. This thing is very important. In this business, when they give you a tube size, it's always the outside diameter. All right. All right. So if they tell you the boiler has 3-inch tubes in it, they're telling you the outside diameter is 3 inches. All right. Any tube greater than 4 inches is what we call a flue. Some of you might have heard that term. Or they used to ask second firemen, what's the difference between a tube and a flue? And a flue is just a tube greater than 4 inches in diameter. All right. The bottom line is these HRT boilers, which they made right up till the 1950s, had a pressure limitation of about 250 PSI, and they were good for about 25,000 pounds of steam per hour. All right. But think of it this way. This boiler was the grandfather of the modern package fire tube boiler. Everybody kind of see the similarities? All right. Good. All right, the next board. Now, think about this. The early boilers, what they did, they filled a shell with water and they built a fire underneath it. Shitty way, a very slow way to boil water. Didn't take them long to figure out this. If I put tubes through the water and I pass the products of combustion inside those tubes, I will expose more of the surface of the water to the high temperature of combustion, and the water will boil faster. Everybody kind of get that, right? They figured that out. All right. About the time of the Civil War, a guy in Scotland figured out this. He said, if that's true, why don't we put the entire furnace inside the shell of the boiler and have the entire furnace surrounded by water? All right. That boiler, that concept became known as the Scotch marine boiler. All right. So now the furnace is inside the shell of the boiler. All right. And I no longer need a brick setting. All right. This boiler caught on like wildfire, especially on ships. Hence the name, the Scotch marine boiler. It took up a lot less space. It weighed a whole lot less, all right, than the HRT boilers that came before it. All right. Probably the most famous ship to have these boilers on it was the Titanic. The Titanic had 30 Scotch marine boilers. There were 150 firemen on that ship. Each fireman was responsible for shoveling coal into 2 of these boilers. Each boiler had 3 furnaces. All right. You worked your ass off. All right. Not only that, this boat didn't make it. All right. Remarkably, though, about 3/4 of the firemen lived. This boiler is really considered the father of the modern package fire tube boiler. All right. So the bottom line is this. Today, if you have a fire tube boiler, it looks like this. All right. These boilers are extremely efficient. All right. The products of combustion make 4 passes through the water. All right. This is a key point in boilers. When you operate boilers, the exiting flue gas temperature, you want it to be as low as possible. The lower, the better. All right. It is a direct indication of boiler efficiency. All right. Remember this, and this is a question they'll ask you on the state exam. What is the biggest heat loss in any boiler? And that's heat loss out the stack. Now, I think everybody kind of gets this concept. Let me just run through this. If I have a boiler, we'll make it real simple. And the air I'm bringing in today is 70 degrees. I mix that air with fuel. I burn the fuel, and the flue gas goes out the stack. All right. If this boiler was 100% efficient, what would be the temperature of that gas going out the stack?
70 degrees.
70 degrees. Excellent. All right. That means all the heat developed by burning the fuel was absorbed by the boiler. And none of that heat is being rejected to the atmosphere. In a typical boiler, though, guess what we're looking at for an exiting flue gas temperature? Anybody want to take a guess? Anybody know the number?
Isn't it like 70% efficient?
Okay. Anywhere from 300 to 450 degrees Fahrenheit is the typical exiting gas temperature from most boilers. And today, a modern boiler is 85% efficient. Anybody have any idea how hot combustion is? Nobody?
What is it? Fire starts at like 512 degrees or 519 or something.
The average combustion temperature, and I'm talking in an internal combustion engine in a boiler, is 2,500 degrees Fahrenheit. Right? This boiler, once you burn the fuel, it produces heat at 2,500 degrees. Going out the stack, it's 300 to 400 degrees. That's pretty amazing. Right? Everybody kind of agree?
Yeah.
Right. Just to put things in perspective, how efficient do you think your car is? Your gasoline powered automobile.
40.
Not bad. That's a pretty good guess. About 30% efficient. Right. They're dogs with wheels. All right. Now you get a hybrid or electric car, you might do a little bit better, but 40% is the outside. So boilers that are 85% efficient, pretty good. Everybody agree? All right. It's a good deal. All right. All right. So what do I want you to take away from this? What's the biggest heat loss in the boiler?
The exhaust.
Out the stack. All right. What's the biggest heat loss in an automobile?
Out the
The
exhaust.
Out
exhaust.
the exhaust. Beautiful. Beautiful. You're getting the whole idea of it now, right? All right. Now, the packaged fire tube boiler, all right, are everywhere. That's why so many of you have seen these. All right. What they're going to ask you on the state exam is, why is that? What are the advantages of these packaged fire tube boilers? All right. They're low cost. All right. You can buy one of these things for about 100 grand. All right. Doesn't sound cheap, maybe. They're turnkey operation. What do I mean by that?
Ready to go.
They're ready to rock and roll. They're built in a factory somewhere. They ship it to you. You hook up electricity, water, steam lines, and away you go, fat, dumb, and happy. All right. They don't take up a lot of space. There's no setting. And what everybody loves about them, they're automatic. All right. Does anybody operate a package fire tube boiler at their job? Tell us about it, Dan. David, I mean, sorry.
Oh, okay. Yeah, we have a couple of low pressure fire tube boilers. They're pretty straightforward. They look just like the pictures you see here. There's not much difference.
Are they automatic?
I wouldn't say completely automatic.
Yeah. What do you got to do? Start them and shut them down?
Yeah, that's basically about it.
Yeah, that's pretty much automatic, right?
Yeah.
All right. What's the downside to these boilers? All right. They don't make a lot of pressure and they don't make a lot of steam. All right. They're very limited. All right. To get inside them is difficult. So to do an inspection, clean them, is tough. All right. They're relatively slow steamers. And guess what they can't burn? Any solid fuel. They can burn natural gas and oil only. Everybody gets that, right? Now, just to make sure I'm not misjudging this crowd, does everybody kind of get what we can burn in boilers today? We burn everything. All right. In Massachusetts, we have about 10 trash plants where we burn garbage to make electricity. All right. We have a couple of wood burning plants that burn pallets, trees. All right. We have coal burning plants.
Where's the wood burning plant?
Well, there was one in Fitchburg. Most of them have moved over to New Hampshire now because Massachusetts regulations kind of drove them out. There's a guy in Springfield burning used tires in a boiler and producing electricity. All right.
Wow.
So you can burn anything you got laying around the yard in a boiler. You just can't do it in a fire tube boiler. All right. So that's what they mean. All right. But let me tell you this. If you get a job running a package fire tube boiler that runs natural gas, you died and went to heaven. All right. There is absolutely nothing to do. Does anybody have such a job? No? Joshua, what fuel do you guys burn?
Natural gas.
Yeah, pretty simple, isn't it?
Yeah.
Did anybody here ever burn fuel oil? That's what pisses me off about you younger people. You're never going to see a boiler burning fuel oil in Massachusetts. All right. That was a pain in the ass. All right. But anyway, the next boiler to come along was the water tube boiler. All right. Water tube boilers, on the other hand, now can be built unlimited capacity and almost limitless pressure capability. We can build water tube boilers operating over 5,000 PSI. All right. They can build a water tube boiler and have it fit whatever space you got. They can make package water tube boilers. All right. They can build water tube boilers with heat recovery equipment. All right. And I'll talk about that in a minute. But water tube boilers can burn any fuel. Right? Everybody kind of get that. Is that a good thing?
Yeah.
Yeah, why not?
If
Right?
you're running a garbage dump, that would be a great boiler to have.
That's the boiler they use. All right. So everybody kind of gets it. The first water tube boiler was built by a couple of local boys, Babcock and Wilcox. Some of you might have heard of that company. Today, they build most of the nuclear reactors. They still in the business of building water tube boilers. All right. What they were looking to do were three things. Build a safer boiler. And their argument was pretty simple. Have the water circulate in the boiler in small diameter tubes. That way there, if you get a tube leak, it's a minor incident. It's not a big deal. All right. They also wanted to produce superheat, something you couldn't really do all that easy in a fire tube boiler. All right. And finally, they wanted to eliminate all flat surfaces. All right. All right. That was their objective. Get rid of all the flat surfaces in the boiler. They almost did that. All right. This shows you a single line diagram of this boiler. All right. The products of combustion, the fire started in the furnace. The hot gases flowed through the boiler, following this line, and out the breeching and out the stack. All right. Any questions? All right. Around the same time, a guy in Germany named Heine came up with his design of a water tube boiler. All right. They don't make these boilers anymore. The only reason I'm telling you this is if the inspector holds up this picture, you're expected to recognize this as a Babcock and Wilcox longitudinal drum water tube boiler. All right. It's not a fire tube boiler. All right. The first water tube boiler that they built that had no flat surfaces whatsoever was this Stirling boiler. This one was called the Stirling 4-drum boiler. All right. Pretty clever how they named that, huh? 4 drums. All right. Now, one of the big advantages of water tube boilers is that today we can add heat recovery equipment, all right, that further reduces the exiting gas temperature from the boiler. Let me make sure that everybody understands this, all right? I have a big boiler. And I'm going to attach it to a smokestack. And you already know the answer to this question. As I burn fuel, mix it with air, I produce flue gas. And the flue gas is going to go out the stack. Everybody buys that, right? How do I reduce the temperature of this gas? All right. I put things in its path. All right. For instance, if I take steam and I run it through a pipe, this pipe, the steam will absorb some of the heat of combustion and lower the stack temperature. Everybody buy that? If I have water on its way to the boiler and I pass it through an economizer and heat up that water before it gets to the boiler drum, is that going to further reduce the exiting stack temperature? If I put an air preheater in there and preheat the air that I'm going to use in the combustion process by reducing the stack temperature, that's going to improve the overall efficiency of this boiler, isn't it? All right. So does everybody get that this heat recovery equipment does one thing? It lowers the exiting flue gas temperature to improve the boiler efficiency. All right. This boiler here, sorry, is equipped with an air preheater. The hot gases from the boiler go inside the tubes. The cold outside air travels outside the tubes and gets heated up on its way to the boiler furnace. All right. You can make water tube boilers as large as you need them to be. This shows a giant coal burner. Here's the size of a person relative to this boiler. These boilers are 10, 12 stories tall. All right. So if I need a lot of steam at a high pressure, what boiler would I prefer to use?
Water type.
Water tube boilers. All right. Keep in mind that about 95% of the boilers in Massachusetts are fire tube type boilers. All right, we've been going at this for a while. Why don't we take a 10-minute break here? Is that right? I'll see you in about 10 minutes. All right. Guess it's time to get back at it here. Now, I've shown you different styles of boilers, both fire tube and water tube boilers. All right. Where's this going? On the state exam, they're going to ask you, can you name 3 types of fire tube boilers? So I'll ask you, the class, can you name 3 types of fire tube boilers? Well, go ahead. Well, let's start at the beginning. Today, we talked about the vertical fire tube boiler,
Horizontal and packaged.
the HRT boiler, horizontal return tubular, the Scotch Marine, and the modern package fire tube boiler. Those are all examples of fire tube boilers. All right. Everybody buy that.
Yep.
All right, good. All right. Now, I know it's still kind of early in the game. All right. When they ask you to name water tube boilers, all right, one of the things that are pretty common in this industry is to name the boiler by the manufacturer's name. Does anybody remember the name of this boiler?
Babcock and Wilson.
Babcock and Wilcox. Very good. B&W. All right, easy way. The Heine boiler. Anybody remember the name of this puppy?
Sterling.
The Sterling boiler. All right. All right. All right. This is a combustion engineering boiler. All right. Many of the water tube boilers today are classified by the letter they form. All right. You could see the D type, the A type, and the O type water tube boilers. Right. We have giant industrial, all right, utility boilers. All right. Some of these boilers can burn trash, garbage at a garbage plant. All right. So let's get down to the real basics. All right. You ready to make a couple of notes here? All right. Fire tube boilers today. They produce steam that's about 95% quality. What am I telling you?
There's some water in it.
Excellent. Excellent. It's that simple. How much water?
5%.
Excellent. If I told you it's 95% quality, I'm also telling you that it's 5% moisture. All right. This is fine because most fire tube boilers are used exclusively to heat up a product. All right. We don't care that there's moisture in the steam. Today, most water tube boilers produce steam at about 98% quality. Meaning what?
2% moisture.
Excellent. In a perfect world, steam that's 100% quality would have how much moisture in it?
0%.
Excellent. It's that simple. All right. Now, the question becomes, how does a fire tube boiler do this? Right? In every fire tube boiler today, there's a piece of equipment attached to the steam outlet called a dry pipe. Has anybody ever heard of this term before? All right. The dry pipe is nothing more than a perforated section of pipe. As steam and water enters this pipe, the steam has to change direction. When it changes direction, the water droplets get thrown outward, all right, producing steam of about 95% quality. All fire tube boilers are equipped with a dry pipe. His buddy, the water tube boiler, is a little more sophisticated in that it does a little bit better job of producing higher quality steam. All right. The problem in the water tube boiler is this. The water, due to the size of the boiler, is generally coming back at high velocity. All right. What I don't want to happen is that water laden with steam, or that steam laden with moisture, heading right for the steam outlet pipe. So water tube boilers are constructed with what they call cyclone separators and scrubbers. All right. The cyclone separator is nothing more than a can that the steam and water enter, and it develops that cyclonic motion as it tries to work its way out. As it does, water droplets get thrown back to the surface. Once it passes through the cyclone separator, there are a series of baffle plates that basically causes the steam to change direction multiple times before it goes out the outlet. All right. That's how water tube boilers separate moisture from the steam. Cyclone separators and scrubber plates. Any questions? All right. Now, earlier today, I told you what is the highest pressure any specific boiler can operate at.
It's maximum.
Excellent, excellent. Does everybody remember that? MAWP, maximum allowable working pressure. That's the highest steam pressure that a particular boiler can operate at. It's MAWP. Excellent. Now, earlier tonight, I used the term saturated steam. All right. Let's see who remembers fourth grade science. All right. At what temperature does water boil?
212.
Well,
212 Fahrenheit.
Excellent. At what pressure is that?
Atmospheric.
Atmospheric pressure. Excellent. And the steam that I generate off that 212 degree water is what temperature?
212.
212 degrees. Excellent. Now I have a boiler that operates at 100 PSI. What temperature does the water boil at? Higher or lower?
higher
Oh,
temperature. Higher pressure. Temperature, yeah, same thing.
What temperature is the steam coming off this boiler?
I want to say 327 degrees.
Exactly right. All boilers produce saturated steam. That's exactly the same temperature as the water from which it was generated. At the critical pressure, 3206 PSIA, the boiling point of water is 705.4 degrees Fahrenheit. The point of the story is this. For every pressure, there's a corresponding saturation temperature. The saturation temperature is the temperature at which water boils. Now, there's only one way that we know of to make superheated steam. To make superheated steam, I have to remove the steam from contact with the water that it was generated from, pass it through some tubes that the hot gases from the boiler are passing over. This will elevate the temperature of the steam, so it now becomes superheated. It's at a temperature higher than the saturation temperature. All right. Is that a good thing?
Yes,
Why?
more energy is being conveyed.
Okay, very good answer. More BTUs for each pound of steam, which means I need less steam to accomplish a particular task. Superheated steam, good. All right. Excellent. So that was pretty painless, right?
Yep.
Okay. Fire tube boilers cannot produce superheated steam. You might get a couple of degrees, but to produce superheated steam, you need to do it in a water tube boiler. All right. Earlier today, I mentioned a couple of things.
Quick question, can you take a fire tube boiler, take the steam out of it and then superheat it from there?
Not without great difficulty.
Okay,
All right. Yeah, could they do it? Yeah, they tried all kinds of devices. Were they reliable? No. All right. Just not a good fit. All right. But that's a good question. All right. That's why Babcock and Wilcox said we got to go with a water tube boiler so we can make superheated steam. Now, earlier tonight, I mentioned the term manhole.
yep.
All right. Can anybody tell me what a manhole is?
It's a sealable opening that you use to inspect a boiler.
Okay. All right. This opening right here in this steam and water drum, that's a manhole. With a boiler in operation, it's covered by a plate with a couple of yokes that secure that plate against the edge of the drum. All right. A manhole is to allow access for a person to get inside the vessel. All right. If that's true, then what is a handhole?
Would be just for, be able to put a hand in, I would assume.
A handhole is a small opening that a person cannot fit in, but he can stick his hand in there, stick a hose in there to flush it out. All right, to remove any scale, sludge, or sediment. All right. Now, manholes have two basic shapes to them. All right. The most common manhole is elliptical or oval shaped. Does anybody know why?
I do, so it can, it's put inside the vessel, and so the pressure keeps it sealed.
Yep, that's good. That's true. That's exactly true. All right, but why is it oval shaped? So we can take it out of the vessel. We can turn it on its edge and remove it. If the manhole was circular, perfectly round, could I do that?
No.
It wouldn't fit out the hole. All right. The manhole has to stay inside the boiler, even when it's open. Does everybody kind of get that?
Yep.
All right. The oval shaped manholes originally were 11 by 15 inches. Doesn't sound very big, does it? That's the minimum size. In 1987, the ASME code figured out that people are getting fatter. And they said the minimum size for a manhole is 12 by 16. Not much of an improvement, is it? All right. A circular manhole, a perfectly round one, has to be a minimum of 15 inches in diameter. A handhole has only one size. They're also oval shaped. They are 2 3/4 inches by 3.5 inches. Manhole, I can get inside the vessel for cleaning and inspection. A handhole, I cannot get inside. All right. All fire tube boilers have a manhole. Sorry. Just bear with me a second here. On top of the shell. All water tube boilers have a manhole at both ends of the water tube or the water, steam and water drum, and both ends of the mud drum. All right. Any questions? So there'll be a manhole opening at either end of the steam and water drum and a manhole opening at both ends of the mud drum. Has anybody ever been inside a boiler? Joe, you have?
Yeah, it was like an initiation.
Yeah. What type of boiler? Fire tube or water tube?
Cleaver Books fire tube. You know,
Oh, yeah. Pretty
They don't-
tight in there, huh?
yeah, well, they opened it up and said, "Oh yeah, go inside, look around." As soon as you get in, I knew they were going to do it. They put the cover on.
Yep, they pretend they're closing it up. Yeah, the oldest trick in the book.
Yeah, just don't
Right.
freak out. That's all.
All right, all right. So everybody gets the difference between a manhole and a handhole, right?
Yep.
All right, good. All right. Just trying to show you, right here, this is the manhole cover with a couple of yokes holding that plate tight against the drum to keep it shut. Obviously, as the pressure inside the boiler builds up, you're expected to go around with a wrench and tighten up on these nuts. And that'll tighten that manhole. Does everybody get that? You're going to use the pressure, the internal pressure of the boiler to help seal that manhole or handhole. All right. Pretty good. All right. Just want to make sure I cover everything. All right. One last thing, and then I'll send you the homework and let you go for tonight. All right. In boilers, water tube boilers especially, they have an expression. All right. The tubes that are closest to the fire are what they call risers. All right. In those tubes, water is heated first and it rises up because it's less dense. The tubes furthest from the fire are what they call downcomers. That's where the cold entering feed water at its most dense is the heaviest, and it sinks. That downward motion and that rising motion is what causes natural circulation in a boiler. Does everybody get that? The temperature differential between the water already in the boiler and the entering feed water. Guess where these kids don't work?
In Massachusetts.
Yeah, how about anywhere in the United States? All right. These guys are actually installing the scrubbers in the drum of a water tube boiler. All right. We don't have any jobs that allow you to work with sandals and Bermuda shorts with no shirts. All right. All right. But this gives you an idea the size of the drum in a water tube boiler. All right. You can get in there, kind of get in there nice. You can't stand up. All right. It's pretty painful. All right. There's a lip on all these tubes. All right. Has anybody ever been inside a water tube boiler? All right.
I just have a question about, I thought the scrubbers were connected to the cyclone separator.
They are.
Okay,
Yeah.
okay,
But to install them initially, the first thing I need are some brackets. So what they've done, they've installed these brackets. And that what will happen, that'll support the cyclone separator. And then at the top of the cyclone separator, there'll be the scrubber plates or the baffle plates.
thank you.
So they're just getting underway, but this is basically what it will look like when they're done. All right. So there's a lot going on there. Remember, the difference in the water tube boiler is the water's coming back to the drum at relatively high velocity. All right. All right. One last thing. All tubes, when we give you the size of a tube, what dimension are we giving you?
The outside.
Outside diameter.
Outside diameter. So the question becomes, what's the difference between a 3-inch water tube and a 3-inch fire tube? Think about it.
The
In a
3-inch
water tube, where are the products of combustion?
outside the tube.
Outside the tube. In a fire tube, where are the products of combustion?
Inside.
Inside.
All right. For the tube to work, it has to have a wall thickness. All right. Does everybody get that? In this case, if I told you that the wall thickness was 3/16 of an inch, what is the internal diameter of this tube?
Two and 13/16.
No.
No, it would be
Yeah.
minus 6/13 would be 3/8 minus 3/8 off the whole diameter.
Okay, 3/16 times what?
2.
Two. And that equals 6/16, right?
Yep,
And another way of saying that is
3/8.
3/8. If I subtract 3/8 from 3 inches, what's the ID?
2.
5/8.
Yep,
2 and 5/8. One of the math problems they have on the state exam is for you to calculate the ID given the wall thickness of a tube. Does everybody get that?
Yep.
So you take 2 times the wall thickness, bring it to its lowest common denominator, in this case 3/8, and subtract that from 3 inches. All right. Why do they want you to be able to do this? One of the big calculations in boilers is heating surface. Right? Heating surface is defined as the parts of the boiler with the products of combustion on one side and the water on the other. Always measured on the side receiving the heat. So in a fire tube boiler, heating surface is based on the inside diameter of the tube. In a water tube boiler, it's based on the outside diameter of the tube. Right? I know I said that was the last thing, but let me give you one more thing. You'll notice in this boiler, and this boiler comes from the 1940s, what they've started to do is make the walls, the ceiling, and the floor of the furnace out of tubes. This technique is known as water wall construction. All right. What that does, it makes sure that every square inch of the boiler is heating surface. It produces steam. If you were to buy a modern water tube boiler, every square inch of this boiler is made up of tubes, small diameter tubes that form the walls, the ceiling, the floor of the furnace. Water wall construction. All right. Water wall construction is only available in water tube boilers. Right. What do they call this lower drum?
Mud drum.
Mud drum,
Why do they call it the mud drum?
where all the sediment goes from the top drum.
Excellent. All the sludge and sediment will settle there, and guess where the blow-off pipe is attached to? The mud
Bottom of that
drum.
drum.
Yeah, so when you blow it down, you get rid of all that crud. All right. All right, I think that's enough for tonight. Any questions?
Is the homework due on Wednesday?
The homework is always going to be due on Monday. I'm going to send it to you tonight. So you got a week now to fool around with it, look it over. Tonight, what you'll get on the email are the answers to homework 1 and the questions for homework 2. Did everybody get the schedule that I sent you today? I just want to make sure I got the right email for everybody.
Yes.
Very good.
Yep.
Very good. All right, then. I'll see you Wednesday.
Awesome. Thank you.
You.
All right.
Good night.
Hey, Tom, can I ask you a quick question?
Absolutely.
So, I got my seconds now, my second fireman.
Yep.
Trying to decide if I want to go for my first or skip right to my third engineer.
How long have you had your seconds?
Be a year in September, I think, but I've been working with the second fireman since October.
All right. So what they tell us is for you to skip first fireman, you have to have held and used your second fireman's license for a year and a half.
Oh, okay. I thought there was like a little clause about if you were working with it, it was a year. or
No,
something.
the clause says this: if you have a second fireman's license and you work 6 months, you can sit for first fireman.
Okay, all right.
If
So
you
do
go a year and a half, you can skip first fireman and go for third engineer.
So you think I'm better off just finishing the class and waiting to take the thirds, or should I go for my?
Well, it all depends on your situation. Is there more money for the first fireman?
Nah.
All right. So then there's really no incentive for you to get that license.
Okay.
You're not gonna get any more money. But with the thirds, you could see a substantial increase in money.
Yeah, that's what I'm thinking.
Yeah.
Well, I
So
got you.
the thing is, I would recommend waiting a year and a half and going right for the thirds.
So finish this class and then just study for a couple.
Study, yep. And unless things change and unless they say, hey, we'll throw you an extra $3 an hour if you get the first fireman.
Yeah, which they're not gonna do, but if they
Yeah.
did that, I would definitely do it.
Right.
But the other thing, like, I don't work, so I work in a utility plant, right? Our boilers, we got 4 Cleaverbrooks, but we're not producing steam. We're just heating.
Yep.
The only reason we even need our firemen is we got like small little 100 PSI autoclave ones. That gets us through the loophole. Will that still count for me?
Oh, absolutely.
It will count. Okay.
Any boiler producing steam counts as an operating time.
Because the big boys we use are just, they're heating. We got heat exchangers where it's basically a condensing water plant.
Yeah.
With heat exchangers, all that. It's at UMass Boston.
Yep. I know the place. Yep.
Okay, yeah. So you know what I'm talking. So it
Yeah.
does count just even with the little autoclave 100 PSI ones.
Yeah. If they're not going to throw you any more money, there's really no incentive for you to do it.
No, so I should just hold off and just finish the class and then just study for a couple of months and know my shit inside and out and then go bang the test out.
Go for the thirds. There you go.
All right, cool. I just wanted to get your opinion. That's what I was thinking I was gonna do.
Yeah, I think that's the right way to go. Now, things could change. You might find a job at another college where they need a first fireman.
Right. Now, a buddy of mine just got a job at Pfizer, and he was like, "Oh, they might be looking for a first fireman, and if it's more money, I'll go be like, shit, I'll just go take the test."
Yeah, that's the thing that drives everybody. If there's more bucks, I'll do it.
I'm looking for one of those continuous plants because ours is not continuous, and I'm doing way more mechanical shit than I want to be doing.
Yeah, you're doing a lot of walking around, right?
Yeah, well, I'm doing a lot of repairing pieces of shit, heat exchangers, strainers, pumps, things that haven't been touched in like 15 years. So
Yeah, I knew a couple of guys that worked there. In fact, they took the class on a tour there once. And one of the operators told me they walk an average of 11 miles in a shift.
Yeah.
Because the buildings are so far apart. And there's equipment in every building that's got to be checked on.
We do our rounds and now we got like labs and everything else. So it's a massive pain in the ass. I'd rather just sit in a continuous plant.
Yeah, it keeps you in good shape, but yeah, it sounds like a pain in the ass. Yeah.
I'm still fat. Doesn't keep me in good shape. Cool. All right, then I'm gonna do that. I'm just gonna take the class and then I'll just study for like 4 or 5 months, keep my shit sharp, and then just sit for my thirds then.
Yeah, that's probably your best move.
All right, Tom. Thanks, man. I appreciate it.
All right, no problem.
Take it easy.
All right.